Hey, welcome to the Chapter 4 review. I am your host, Mrs. Stevenson. So let's go ahead and get started. This chapter is all about graphing, and in particular graphing lines. So number one, we start off just simply by graphing 4 points and labeling them. So the important thing to remember here is that points are in a certain order. The x value comes first, the y value comes second. And so the x, since our x-axis is going left to right, this means that we'll go left or right first for the first number, and then we'll go up or down for the second one. Which direction we go, left or right, up or down, depends on whether it's positive or negative. Now, if you've already done a whole chapter of this, you might think about slope and think it's the opposite way. So graphing points, you do left or right first, up or down second. Slope is where we do, we make the top number be our up and our bottom number be over. So there's a difference. This is a point, slope is a fraction, so we do different things. So let's try this. We're going to graph 3, negative 3, so I'm going to go right 3 and down 3, because I've got a positive and then a negative. And then when it asks you to label a point, if it has letters like this, then it probably just wants us to label with the actual letter. If it didn't have letters, then we'd actually label it 3, negative 3. So then we're going to do B, 1, 6, so that's positive 1, and then positive 6, so that's all the way up here. And we're going to do C, negative 2, 0. That means go left 2, but don't go up or down at all, because our y value is 0. So that's C. And then D is 0, 1. So this time we're not going left to right at all because the first coordinate is 0, but we are going to go up 1. And so there's A, B, C, and D. The second thing are the following ordered pairs of points on the line 3x minus 4y equals 16. We can figure this out without actually graphing the line, although that would be one way to go. What we can do is we can take our x value and our y value here and plug it in for this x and y and see if what we get is true. If it is, then it would be on the line. If it's false, then it would not be on the line. So we're trying to figure out, is 3 times 0 minus 4 times negative 4, is that equal to 16? Well, 3 times 0 is 0. Negative 4 times negative 4 is a positive 16, because when we multiply negatives together, if there are 2 of them, they cancel each other out. So does 0 plus 16 equal 16? Yes. So we would answer the question by saying yes, it is a point on the line. But yes is good enough. And then we're going to do the same thing with B. So we're going to put the 4 where our x is. And then we're going to do minus 4 times negative 1. Make sure you don't forget these negatives that are floating around because it can make all the difference here. 3 times 4 is 12. Negative 4 times negative 1 is positive 4. So we're trying to figure out if these things are equal. 12 plus 4 does equal 16. So this is also a yes. So there was an example here that was a no. A no would be where if we got like up here, if we had gotten 12 minus 4, well, that would be 8, and 8 doesn't equal 16, so we would say no. The next 4 questions here are vocabulary type questions. So it says, on the graph provided, label the x-axis, the y-axis, and the origin. Now, the entire rest of the review, and also this happens on number 1, actually labels the x and y axis for us. So a test-taking strategy that happens in any class you take actually is that sometimes there's a way to use other parts of the test to help you on a certain particular question. And so this would be a case where if you realized, okay, it's telling me on other graphs that this is the x-axis and this is the y-axis, then that can help you. Hopefully we just know which one is which. That would be the ideal situation. But if you forget or panic or something, see if it's somewhere else on the test. The origin is where our graph starts in the middle, which is 0, 0. So this point where our lines meet is the origin. On number 4, on the line provided, we're going to label the x-intercept and the y-intercept. So again, thinking about where, or later on in the review, we might have helpful information. We graph the y-intercept from slope-intercept form. So this has to be the y-intercept because that would be the point that we would graph first if we knew this equation, which means that this point right here would be our x-intercept. And so our x and y-intercept are just telling us the places where our line goes through each axes. And so since this is the y-axis, this is the y-intercept. Since this is the x-axis, this is the x-intercept. In math, we have times where we'll have different forms for an equation. So slope-intercept form is y equals mx plus b. Because if I wanted to talk about an equation and I want it to be in slope-intercept form, it has to be y equals a number x plus another number. The m and the b represent things about our line. The m is our slope, and the b is our y-intercept. Number 6, what does the slope of a line tell you about that line? What I'm going for there is that the slope is telling us about a certain quality that our line has, that if we don't know that quality, we can't graph a unique line. That quality is how steep the line is, so that's one of the things we could say. How does the slope of a line tell you? What does the slope of a line tell you about that line? It tells you how steep the line is, because the slope is what tells us the difference between this line and this line, for instance. Maybe like those are definitely not the same line, and one of the things about them is one is steeper than the other, one's going up faster than the other. So there's other ways that you could word that, but that's the idea, that it's telling us about the angle it's going up, it's telling us how fast it's going up, things like that are what we're looking for. So the whole rest of this review is just a whole bunch of graphing practice. And so the instructions tell us to sketch the graph of each line. And so we just have to remember we start with the number that is being added or subtracted. So this -1 is our y-intercept, which means we put it on the y-axis right here. Make sure you put it on the y-axis, not the x-axis, and make sure you put it at -1, not +1. And then we use the slope, 6/5, to tell us our up and over. Or usually in math class, we actually call it our rise over, our run. Both of these get the same idea across, that we want to go a vertical amount first and then a horizontal amount. Now, what's tricky is how to deal with positives and negatives. So a positive 6/5 means we're going to go up and to the right, because those are both positive directions. So I'm going to start at -1, and I'm going to go up 6 and right 5 and put my next point. Teachers want you to not be super messy here, but I would imagine most teachers are like me and care way more about where your points are than how straight your line is. So by all means, use a ruler if it makes you happy, or to use a ruler if it makes you feel better. And if you don't want to get crazy with your lines and make them look awful, but just know if it's not a perfectly straight line, that's okay. It's the points that we really care about as math teachers. So let's look at this next one, number 8. So 4 is our y-intercept, so it starts at 4 on the y-axis. And then this time we don't actually have a fraction for our slope. We're going to make it a fraction by putting it over 1. And so then, since it's over 1, we are going to have to go down this time because of our negative, and then over 1. So we're going to go down 7 and right 1. Now, you might be thinking, why is it right 1 instead of left 1, since it's a negative slope? Well, if I do that, I end up with this same slope that's the same direction. Negative slopes should be the opposite direction. They should be going down and to the right. And based on the number is if I have negative 7 over 1, that negative is really only going with one of the two and not both. Either I need to think of this like negative 7 over positive 1, or I could think of it like positive 7 over negative 1. But if I try to think of it like negative 7 over negative 1, well, those negatives should have canceled and given me a positive. So if I think of it this first way, I'm going to go down and to the right. If I think of it this second way, I'm going to go up and then to the left. We don't have room to do this second way, so I'm going to have to go down 7 and right 1. This is a very steep line. So you really got to watch out on those negative slopes to make sure that you put them the right way. All right, we've got a y-intercept of 5. A negative slope, so we can think of that like down 5, right 2. If we didn't have room to do that, we would try to go up 5 and left 2. When we don't have room and have to go the opposite way, we have to switch both of them. Like we want to go the complete opposite direction. So down 5, right 2. This actually has room for us to do another point if we wanted to. Some teachers like for you to put a whole bunch of points. Some are indifferent. I need at least 2 personally to be able to tell what your y-intercept and your slope are. And then anything after that is just going to make your line more accurate. 10, we start with negative 1. It can be really easy to accidentally start putting this in the wrong spot. So make sure you always think y-intercept on the y-axis and pay attention to positives or negatives. Now there's not a number in front of x, which means that secretly there's a 1, and that 1 is really 1 over 1. So it's a positive slope, so we're going to go up and over 1 and 1. And since it's such a short kind of distance to go, there's plenty of room for points, both directions. And so you see if I draw my line back the other way, see how to make these other points I would go down 1 and left 1, which is the exact opposite of what we did the first direction, because down 1 and left 1 is 2 negatives, which would still be a positive. So that's how that works. More graphing. Let me line this. Okay, now this one's tricky. When there's not an x and a y, we do things differently. The x and the y together is what is making our line diagonal instead of either vertical or horizontal. So whenever it's just an x or just a y, we need to realize that it's horizontal or vertical. X equals is a vertical line. And so when we see this, we can say I'm going to put negative 1 on the x-axis, which is right here, and then I'm going to draw a vertical line. Now the reason we draw a vertical line is that this line is supposed to be all the places that have a coordinate of negative 1 for x value. So like negative 1, 0, negative 1, 1, negative 1, 2. Those are these points right here that form a vertical line. The other way to remember it, though, or an easy way to remember it, is I'm going to put a negative 1 on the x-axis, and then I'm not going to draw the way my x-axis goes. I'm going to draw the opposite way. Okay, so our graph goes the opposite way as the axis that has a similar name. And so here in just a moment on 14, we'll do the opposite. We'll have a horizontal line. Well, let's not get ahead of ourselves. Y equals negative 2/5 x. There's a plus 0 here that is hidden because why would you write plus 0 when you don't need to? Well, I'm going to write it right now so that I realize, oh, my y-intercept is 0. So if you're ever not sure what your y-intercept is because it doesn't seem to have one, that's the trick, is that it must be at the origin. And then this negative 2/5, I'm going to go down 2 and write 5, or you could go up 2 and left 5. Or you could do both and have an even cooler line. 13 over here has a 1 in front of that x, so this is a negative 1 over 1. We're going to start at 4 and go down 1, right 1, or up 1, left 1. Okay, it's a negative slope, so in general it has to go down and right, as all negative slopes do. They just may do it at a different rate depending on the number. Now, this is y equals negative 4, and so what we're going to do is go to the y-axis and put a dot at negative 4, and then I'm not going to draw it up and down because then it'll be along the y-axis, and I remember that that's not how it works. I'm going to draw it as a horizontal line. That has to do with the fact that our we actually could think of this like it's in slope-intercept form. We could put 0x minus 4, and so we've got a slope of 0, meaning we're not going to go up or down. We're just going to go left or right 1. So it could be a positive 1 or a negative 1. And so here we've got this horizontal line. You can also think about it by remembering that it means that the y-coordinate needs to be negative. And so we can think about some points where our y-coordinate is negative. And then go, oh yeah, that's a horizontal line. Final 2 on this page, and then there's 4 more on the back of it with a little added step. So we start this at negative 1. We're going to put this over 1. We're going to go right 6, not right, sorry, down 6 and right 1. Right. Oh, it's off of our graph, so we should definitely go the other direction to make a point that's on our graph. So if we were going down 6, right 1, and that didn't work out so well, we're going to switch both of them and go up 6 and left 1, which is right here. Now you could argue that that was close enough to the graph that maybe it was okay to just put it off of the graph, but I think all math teachers would prefer you just know, oh, I can go backwards to make this fit on my graph. That was kind of the point of putting the problem on here. So here we have 2 over 1, and we've got a y-intercept of 5, so we're going to go up 2 over 1. Oh no, it happened again. So I'm going to, instead of going up 2 and right 1, I'm going to go down 2 and left 1. And I like to make lots of points because it makes it easier to draw the line straighter. Otherwise my line tends to kind of go off a bit. All right, so the only other thing on here is that we are going to graph when they don't give it to us in slope-intercept form, when we have to, so we have to put it in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, and so the most important part of that for us to be able to write it in that form is that the y is by itself. So we are going to take this equation, x plus y equals 4, and we're going to solve it for y. So we're going to subtract x from both sides. This is what we always do. We always look at this and say, I'm going to add or subtract x over. And then we look at it and decide if we also need to divide by what's in front of y. Because, for instance, here, there's nothing in front of y, so we're good. But on the rest of the problems, there will be something in front of y that we have to divide by. I'm going to start with my y-intercept, and then I'm going to go down 1 and right 1 because this is negative 1 over 1. And so I graphed my line right here. And we're just going to do that 3 more times. So on 18, I'm going to subtract x like I did on 17. But this time, make sure you don't lose that negative. This is negative y equals negative x minus 2. Negative y is not y being by itself, so we're going to have to do another step to move that negative. And the step we do is we divide everything by a negative 1. Because a negative divided by a negative is a positive, but that also has to happen here and here. So it's switching to positive x and positive 2, which means we have y equals x plus 2. So I'm going to start at 2 and then go up 1 and over 1. And last 2 are a little trickier. We've got more numbers. We're going to start off by moving the x. So I'm going to subtract the 8x, When we subtract 8x from both sides, that means that it's now a negative 8x whenever it's on the right. It doesn't switch back to being positive. We subtracted it, so now it's negative. And the 15 is negative because it was always negative. So I need to divide everything by 3 to finish getting y by itself, just like when we solve an equation, and our last step is normally to divide by what's right in front of our variable. So this doesn't simplify, and so we're just going to leave it as negative 8/3 x. If you have a negative divided by a positive, it's still a negative. And then negative 15 divided by 3 does divide and gives us negative 5. So we're going to start at negative 5. I don't have room to go down 8 and right 3, so I'm going to do the opposite and go up 8 and left 3. And finally, we're going to subtract 6x from both sides. I get negative 5y equals negative 6x minus 15. And so I'm going to divide both sides by negative 5. And so we've got positive 6/5 x plus 3. The negatives here cancel, the negatives here cancel. But just make sure you keep in mind, since these were being subtracted before, we're still going to have either addition or subtraction here. It depends on whether those negatives cancel or not. They canceled, so that's why it's addition. And the reason I mentioned that is it doesn't like turn this into a multiplication problem when we do that step, when the negatives cancel. That's not how that works. It's still addition, just instead of subtraction, it's addition. I feel like that got away from me. Okay, so let's start at 3. No room to go up 6/5. Let's go down 6 and left 5. And there's our answer. So as you're going through something like this is a lot of graphing that's on this review. So if you're studying, I imagine it would be a good idea to make sure that you are capable of graphing a line. Otherwise, there's not much on this test that you're probably going to be able to do. So when a teacher gives you a review like this, you can expect like a similar amount of types of questions. Like maybe there's not actually 20 questions on the test, or maybe there is. Maybe there's not 20 questions. Maybe instead, though, it's a similar like ratio of problems, but just made shorter to make sure everybody has time to finish it. So make sure you can graph, and good luck.